There we go. People are connecting. Hello, everybody. Happy summer. Happy cool weather after that long heat wave. I am still recovering. Thanks for joining us today. Today we have Steve Siegel of Siegel & Associates Structural Engineers, as well as Allison Olinsky. We're going to be talking about innovative foundation and building wall systems. I think you're going to find this very informative. I think it's great to have kind of alternative structural foundational systems in our little black book or arsenal when we start working on projects. And so we know what questions we can ask when we start talking with structural engineers. And I think you're going to really find these three different systems very insightful, not only from ease, but maybe cost perspectives as well. And with that, I'm actually going to turn this over to Steve. One other item, I am going to put in the chat the link to the CEU credits. So if you haven't signed up or given the BSA your AIA number for credit, please fill this out. It has been approved for credit, and so everyone should get one learning unit today. So without further ado, Steve and Allison.
Great. Well, thanks, Daniel. Thanks to you and your co-chair, Jessica, for inviting us to present before your committee. I am Steve Siegel. I run Siegel Associates. We're a 15-person structural consulting firm based in Newton, Massachusetts. And we have a niche specialty in residential design that we call ourselves a general practice firm, but probably 2/3 of our work is in the residential area, working in wood frame and steel and concrete and mass timber. We've found over time that a number of our clients have had questions about some of our design solutions that we consider common. And we've put together a presentation on these three foundation system technologies that in an attempt to proactively inform our clients so they have a better idea of when they might consider using them, and they understand them better when they see them on our drawings. And so we've actually pre-COVID, we're doing this presentation in person. It's the first time we've done this on Zoom, and so we're looking forward to it, and we're excited to be able to present to you. So I'd like to introduce you to Allison Olinsky, and take it away, Allison.
Hello, thanks Steve, thanks Daniel. I am Allison. I'm a structural engineer at your soon-to-be new favorite structural consulting firm, Siegel Associates. And I'm here today to tell you a bit about some technologies that we think will make your jobs as designers easier, just to add some tools to your tool belt. I'll be talking about 3 different technologies or construction methods. I'll run through them all and I'll keep it to about 30 minutes, so we'll have plenty of time for questions. So in total, it'll be just under an hour. These are things that we've personally found to be really great solutions to challenges that we try to address for our clients on a regular basis. So I'll give you some technical information, but also some anecdotal information from our experience. And just put your questions in the chat box and we'll address as many of them as we have time for at the end. So here we go. So I'll be talking about 3 different technologies, as I mentioned. So the learning objectives from this presentation are that you're all able to understand the benefits for each system as they relate to building performance, occupant comfort, constructability, and cost. You'll also be able to decide when each system is most appropriate for a given project based on the specific challenges presented. You'll be able to identify the environmental impact of construction and also the final building performance of each system. And you'll also learn some construction details that are code compliant. So one challenge that you might encounter in building design is creating well-insulated and acoustically separated spaces and in a cost-effective way. And one solution is insulated concrete forms, or ICFs. Why don't you show me by way of the Zoom thumbs up reaction, or you're just waving your real human hand around if you've heard of ICFs. So I've got like 3, yeah, maybe 3 out of 10 or 20 on here, 4, 5. So now so maybe we're up to like 8 now. All right, not bad. But I'm here to raise that ratio. I'm wondering like how many of you have also designed a building with ICFs before? Give me another thumbs up. Fewer this time. Maybe just 3. Okay. Cool. It's good for me to know how much experience y'all have with this. So what are ICFs? ICFs consist of 2 layers of foam connected by plastic webs, and then cast in place concrete is poured in between them. And I'm calling the foam forms, but they stay in place for the life of the structure, providing insulation and also your air and vapor barrier. I've mentioned some of these benefits already, like the excellent insulation. The foam alone provides about R23, and you can get much more than that with the whole concrete and foam assembly taken monolithically. Regarding acoustics, the concrete mass and foam insulation, especially the concrete though, provide very quiet spaces that are well acoustically separated from the outdoors and also from adjacent rooms or apartments if you were to use this as an interior bearing wall in multifamily residential buildings. So I'm sure that this table means a little bit more to you than it does to me, but with a 6-inch concrete core, you can get an STC rating of 50. It's also easy to achieve a 2-hour fire rating with this construction. And I want to touch on some of the constructability benefits. The forms are lightweight and can be easily carried and placed by one person. The forms made by Nudura, which is just one major manufacturer that we've worked with, they are 8 feet long instead of the more standard 4 feet, but they're still so lightweight because it's just foam with some embedded plastic webs, so it can still be easily carried by one person. Nudoras in particular are also completely reversible, meaning you can install them upside down or backwards any which way, and they all interlock with each other with the embedded plastic webs. And we're not Nudura reps, but they have a large market share locally and they're easy to engage with and they have very strong technical support, but there are other suppliers out there. So I have a block to show you. I'm going to stop sharing my screen for a moment. All right, so this is a corner block because I couldn't fit an 8-foot block into this office. This is the corner and they all come collapsed and then they fold out. Let's see if I can do this. They just fold out like this. Nifty, right? You can see these foam nubs and that's used so you can just the interlock one on top of the other when you stack them like Lego blocks, you know. These are the embedded plastic webs that you're seeing. Let's see if I can get more of a close-up. They've got these nubs in the, so I'm holding it upside down. Or as I said, if you caught it, there is no such thing as upside down. So you can see that the webs are symmetrical. So this is the bottom one, but then the top one in the back is the same. So the nubs are for installing the horizontal rebar. So I've got some rebar here. It's much more fun if you could play with it in person. So we got rebar. Can we see this? Yeah. So it just snaps in to the webs. So with your horizontal rebar, you could lay it in alternating. So you would lay the first one here and then say the next one on the next higher block, you could lay right next to it. And then the vertical rebar can get just slid in between them. So it stays up easily. Okay, I think that's all I want to show you here. Put this guy down. Okay, look at my screen again. All right, so here is an up close view of the foam. You can see these wavy lines that are stamped in, and those waves correspond with the location of the embedded plastic webs. They're 8 inches on center, so it makes them easy to directly attach your finishes through the foam because you can see where the webs are located. This would include gypsum on the interior, for instance, or brick, wood siding, or stucco, for instance, on the exterior. For wood siding, you typically install wood strapping, just screw it directly to the embedded webs through the foam, and then apply the siding as usual on top of the strapping. Stucco can be applied directly to the foam, and gypsum wallboard also gets similarly screwed to the webs. And contractors have told us that even once the drywall goes up, the webs can be located with a stud finder in order to attach shelving, for instance. The ICF manufacturers provide different types of vapor barriers that you can apply to the exterior face of the foam at the foundation level. I'm not accustomed to seeing a roll-on or I'm not accustomed to seeing any type of vapor barrier being used above grade, but it can be used in that application as well. So Nudura makes a stick-on sheet for the vapor barrier, which is what you're seeing here. And then you can apply a reinforced stucco for the bit of foam that would be exposed at the foundation above grade. There are a number of different ways you could address it, but that's basically to protect the foam against a weed whacker or something just kicking the foam at that grade level. I've talked to a few contractors about ICFs and they really love it. They just hire a certified ICF installer and they meet their new energy code requirements so easily. And they like that they can carry them around very easily. And look, even I could do it. This picture is from a one-day training seminar that was put on by one of the ICF manufacturers. And this was a seminar for contractors. So it was the first of 2 steps for them to get their ICF installer certification. So it's a very practical minded seminar focusing on the details and the realities of installing these in the field. So it's good to know that there are a lot of resources out there for builders to become familiar with this type of construction. ICFs are currently most typically used for foundations, and that's probably because people are already most comfortable with the idea of concrete walls and a foundation, but homeowners have often said that their basement rec room, for instance, is the most comfortable room in their house. So people have asked, well, why not use ICFs to go all the way up to the roof? And that is exactly what we're seeing. They can be used for houses, apartments, or commercial construction. The tallest building to be done in ICFs is 22 stories tall. But I know this is the residential design group within the BSA, so I will make an assumption about the types of projects you work on. So perhaps you're less interested in the tall buildings and more interested in the custom curved forms in any radius, 45-degree corners, and brick shelves. And all the forms can be easily cut in the field with just a little pocket handsaw, maybe 12 inches long, to create any customized vertical profile or openings you can think of. This means they could also be a good fit for renovation projects where, say, you would need to butt the new ICF wall up against an existing rubble foundation wall with an irregular profile. Thank you. All right, I was told my script was up. You can see my cheat sheet. All right, here we go. So construction recently finished on a 4-story, 33,000 square foot apartment building in Fitchburg that uses ICFs all the way up to the roof. And here's a detail of how the floor framing attaches to the ICF wall. This project used metal joists, but the detail is similar for wood floors. So the process is as follows. There's a pair of Simpson products used for ledger attachment. This is the ICF VL target plate that gets cast into the wall. They would call it an ICF VL-W for 2x wood ledgers or ICF VL CW say that 5 times fast, for LVL ledgers. So the CW would stand for composite wood. So on the ground, you would slip your here we go. This is the second piece in the pair of brackets. So on the ground, you would just slide this shelf underneath your wood ledger and screw through halfway so that the screws aren't coming out the back here. Then the target plate gets cast into the ICF wall by you can just kind of tap it against the foam and the tabs leave marks on the foam. And then you take your handsaw, cut the little notches, slide it in. Then the concrete gets poured and this gets locked in place. So once this is up, you can lift your ledger up that's attached to the shelf, and it all gets just screwed through to the target plate. Make sense? So once your ledger is up, the floor framing is not unlike typical wood framed floor construction, where the joists just get hung from the face of the ledger. And here's some photos of the apartment building we did in Fitchburg. Oh, I think they got lost here. I can share those at the end. But the apartment building we did in Fitchburg was a 2-story building with wood roof trusses, and there were wood balconies on the outside, a steel stair in the lobby, and the wood roof trusses just sat on top of the ICF wall and got attached with, similar to the target plate, with light gauge steel tabs that were cast into the top of the wall and then screwed through to the side of the truss. So let's talk about cost. For foundations, contractors have told us that ICFs are completely comparable in cost to conventional formed walls if you count the concrete only. But the difference is that the ICFs also come with the insulation. So compared to a foundation for a finished basement where you're adding a stud wall and insulation anyway to the inside face, ICFs then come in 5 to 10% less expensive. The relative cost compared to above grade walls is pretty interesting to me, since it's changed a lot since I first made this presentation back in 2019. So there's an ICF supplier that we work with that estimated back then that it was about 3 to 5% more expensive than a 2x6 wood frame wall with just, say, R21 fiberglass insulation. And then the minute you deviated from that to get a better insulated wall, either with a double stud wall, closed cell spray foam, or zip system insulation, it became comparable in cost or cheaper to go with ICFs. Now, however, the cost of concrete has not inflated nearly as much as that for lumber, so ICFs are already equal in cost to that for conventionally framed 2x6 fiber insulated stud wall. And when you compare to a better performing wall like a zip R sheathing, spray foam, etc., ICFs are significantly cheaper, in the vicinity of 5 to 15% even. So it seems like a critical mass was reached in terms of awareness and comfort, where builders, designers, and also the general public of consumers are now seeing ICFs as a legitimate building system instead of something cutting edge that was just kind of cool, but then you would go with the conventional system once it came down to construction. The supplier we work with was also recently acquired by a large building materials company, so they're never running into those supply chain issues, which we all know so well. And I'll note that cost comparisons for ICF are most meaningful when the builder has familiarity with the project and they don't give a surcharge due to their discomfort with this new system. All right, so ICFs also reduce the number of trades on a job, because they include structural, insulation, air and vapor barrier, and fastening for your interior and exterior finishes all in one system. It's another reason that contractors like them. All right, number 2. Another challenge you might face as a designer is keeping projects in a tight construction schedule, particularly with regards to foundations. For smaller structures that you might ordinarily build on sonotubes, you have to excavate the site, pour the concrete, wait for an inspection, backfill, and only then can you start to build your superstructure. In addition, concrete piers with sonotubes carry a significant price per pier. Get to that a little more later. And one great solution is micropiles. They're essentially very small scale helical piers, and they just get screwed into the ground in place of a concrete footing. So here we're seeing a shaft with just a single helix at the end. For many applications, they don't require any excavation, so there's minimal site disturbance. Contractor I talked to told me about how they were able to avoid taking out some large trees on a job by just installing the pier right next to the tree. You don't need concrete, but it's still resistant to frost heave, just like a traditional footing. And since there's no concrete, you can easily install them year round. And I want to show you a short video of the installation of a particular brand of micropile that we've spec'd recently, which is Techno Metal Post, or TMP. Their product specifically comes with this green frost protection sleeve, which slides up and down the length of the post in order to prevent the post from heaving due to frost. So how that works is just that the sleeve can slide up and down the post. So if you picture the ground freezing and heaving around the post, it'll only grab onto the sleeve and bring that up and down instead of bringing the post and the superstructure with it. It also comes with a standard U-shaped bracket on the top of the post for attaching your wood beam or post for the superstructure, but Techno Metal Post provides all manner of top brackets, including just a plate, just a flat horizontal plate for maximum flexibility. All right, so here we go. So first he's setting the position and then making adjustments as it's screwed in. So what we're watching here is the post actually being screwed in. This is just one guy. He's controlling the rig with the remote in his right hand. And then with his left hand, he's guiding it around any obstructions in the ground. And this happened pretty quickly. On this job, it took about 45 minutes total per pier because there are a bunch of rocks in the ground that he had to guide it around. But if rocky soil is anticipated, they make a specialized rock pitch helix that has a steeper pitch to more easily penetrate the rocky soil. Without any obstructions, it would probably take about 20 minutes. And in sand, for instance, each post could go in just a few minutes. On a job we worked on in Natick, they installed 6 posts in an hour and a half. So that's just 15 minutes each. And then in addition to it physically being installed faster, you also don't need to wait for an inspection after excavating and pouring a traditional concrete pier with a build footing. So this is for a new stair landing for an existing. Can you guys hear me? All right. This is for a new stair landing for an existing house. The micropiles are great for tight job sites because you don't need to have a concrete pump truck. And you can see that the installation machinery, especially for the smallest size of posts, is quite small. This is a rig. Their big advertising claim is that they can fit through a gate, a standard size gate in a fence. So they were a great fit for this project in particular because there's an existing retaining wall on site and they didn't have to take out the existing walkway up to the house. So you can imagine how disruptive this work would be if a backhoe had to be used for excavating a pier and big footings. They'd have to take out all the plantings and the walk. You might have to start worrying about messing with the retaining wall. So for decks and additions close to grade, this is a really great solution, and we just show the detail. We show the detail on top with where are those details. When they're close to grade, so we would just show a detail where the post just sticks up out of the ground. But for other applications that are higher above grade, say this is a deck over a walkout basement where you have posts that are, 8 feet tall going down onto a techno metal post. So for those applications, we'd want to provide some bracing laterally if it's not well tied into the main house. One option is providing diagonal braces below grade. Basically, they just come in with very small scale posts, and alongside the main post, they'll come in and install diagonals. Kind of think of them as buttresses, bracing the top of the post near grade. Micropiles are particularly useful for small projects or portions of projects like decks, stairs, boardwalks, and sunroom or screen porch additions, but they can also be used for 2- and 3-story construction. The largest project I know of to be done with techno metal post in particular is a 4-story office building, which was all new construction in Canada. TMP is originally a Canadian company, but now they have offices and local installers all over North America and beyond. We could also use micropiles with grade beams if you wanted a continuous foundation approach. It'd just be a matter of having the right cap connection. And just to give you a sense of the capacities of these things, here's a load table in pounds. So I'll walk you through some of these numbers. So for the smallest size post, a P1, which is it's a nominal 1-inch diameter, so it's an actual 2-inch outer diameter. They have about 7,000 pounds of capacity and compression. And then we jump up to almost 34,000 pounds for mid-size post, which they call a P3. And for comparison, here's an allowable load table from Bigfoot belled footings. So for an okay soil with 3,000 PSF allowable bearing pressure, we have 9,400 pounds of point load capacity for what I think of as a standard size footing, which is 24 inches in diameter. And then for a larger 36-inch diameter footing, we're up to 21,000 pounds. So we are about comparable to the load capacities that you get for a micropile. And micropiles have uplift capacity, which a belled footing does not. So Techno Metal Post wants you to contact them for specific withdrawal capacities, but as a rule of thumb, you get about half of the downward capacity in uplift. So for any condition where you would have traditionally used a concrete pier and on belled footing, micropiles make a great alternative. And our clients really love them, particularly because of the cost. I'm looking to get some updated information. So some of these numbers are from about 3 years ago. We had a contractor estimate that a typical round concrete pier with Bigfoot footing, including the excavator, doing the excavation, pouring the concrete, waiting for an inspection, and backfilling, costs about $800 to $900 per pier. Maybe that's close to $1,000 or $1,100 now. And for the job with Techno Metal Post that I showed you the video of, the contractor said that the lightest pier, the P1, good for those smaller applications, costs $120 each. Contractor on a different job said it was about $160, so somewhere in that range. And on a job where we specified the P3 or mid-range size to support a dining room, we were told they cost $400 each. And that one is an updated number. So that per pier cost is all inclusive. Techno Metal Post comes out and does the installation for that price per pier without any mobilization fee. Steve always says he doesn't know how their business model works. We did have a job recently where they wouldn't come out for a job with just one post, but in the deck job in the video, it was just 2, and they came out for that. All right, moving on to the third and last. So let's say now you want your building to have a continuous concrete foundation as opposed to piers where Techno Metal Post might be a viable option. And you also want your building to have frost protected foundations, obviously. You might also have a high water table or concrete availability concerns. And one great solution is a shallow frost protected foundation. kind of a mouthful, but I don't really have to explain it now. It's all it's kind of self-explanatory in the name, but this is what it looks like. So they consist of either a shallow strip footing or simply a haunch slab, depending on the size of the building, and then rigid insulation in one of a number of different possible arrangements. The basic idea is that below a certain depth, the earth has a constant temperature year round. In this country, that temperature ranges from about 40 to 80 degrees, depending on your climate. In Massachusetts, it's about 50 degrees. So if the earth is at 50 degrees all the time below a certain depth, and that depth in Massachusetts is 48 inches. I'm sure you guys are familiar with that 4-foot frost depth. So if the ground has this temperature always, all we need to do is add insulation to trap that heat below the footing. If you trap the heat below the footing, you keep the soil warm and you prevent the soil from freezing and heaving. So some of the benefits are pretty self-explanatory as well, because you're not going down as far. You require less excavation and less concrete. Shallow frost-protected foundations were originally conceived as a solution for slabs on grade for heated spaces, and that's primarily what you'll see outlined in the code. But with engineered solutions tailored to your job, we can do more than that. We can use it for unheated slabs on grade, like a garage, an unheated crawl space, or walkout basements. For walkout basements, it would be very common to use it on that wall over which you would walk out outside of the basement. So this is a great way to meet code for frost protection with less excavation and less concrete than a traditional frost wall, and also to protect the integrity of your structure against frost heave. This is a quick video of the horizontal insulation being installed outside the building footprint. This video is actually for a proprietary system for insulated foundation with slabs on grade, but I've just clipped the portion of the video where they're laying down the flat insulation. So it's pretty simple. You just come in with the big sheets of foam and lay it flat. And we could tell you based on your application what thickness the foam would need to be and how far out you need to extend it. We're watching it again. Okay. So I don't have specific numbers to offer you on the cost of shallow foundations versus traditional, but it's easy to understand why it would be cheaper. There's less of almost everything, less excavation, less form work, less concrete to pour, and less time spent backfilling. And all you have to do is add in the labor of laying the insulation down. But for applications where you're already putting insulation on vertically on the exterior face of the foundation, the laying down the horizontal insulation represents pretty minimal added cost. And in case you're, feeling uneasy about not going down to below frost, we had a contractor we work with pretty often use it on his own house, on his garage. And I'll say that he is one of these contractors that likes to do things by the books, not one of the rogue ones you sometimes have to keep an eye on. And he was more than comfortable not going down to below the frost line with this insulation detailing. And that garage has been in use for probably about 4 or 5 winters now. He hasn't noticed any frost heave on the garage. It's remained level. So that's what I have for you today. Hopefully the next time you're thinking about designing a well-insulated building, you think of insulated concrete forms or ICFs. Next time you're looking for an economical isolated foundation solution, hopefully you think about micropiles, and you can keep shallow frost protected foundations in the back of your mind. So now Steve and I are here to take some questions, and I'll let Daniel curate some of the questions that you all typed in during the presentation. Thanks again.
Thank you, Allison. That was really informative. I was telling Allison at the start of this before everyone came online that after our run through, I immediately identified 2 projects, one for the micropiles and one for the insulated concrete form. So I actually am going to start this off in terms of questions. Could you go through the process if someone is going to be using insulated concrete forms? In the process, I mean by dealing with a structural engineer, or when somebody comes to you, is there a shop drawing process? I mean, because there are parts and pieces here. I've done a little bit of research, and you kind of have to put their system together. Do you do that in your drawings, or do you go to the manufacturer? Could you explain a little bit about the process?
Yeah, so for our job, there was not a shop drawing phase, and at least there was not one that came through the structural engineer. Steve, you can correct me if you think it might have come through the architect, but my understanding is that it is kind of a means and methods, because at the end of the day, it's just a concrete wall with foam on each side.
It's also a system where the parts get assembled in the field. You know, it's really super easy to put these things together from some generic parts and fit them to the dimensions of the project. So I haven't seen them with shop drawings in the past.
Talk about the footing a little bit. Is the footing pretty conventional, or do the ICF manufacturers have something available for footing?
No, it's typically just a traditional continuous footing, and they'll leave dowels sticking up out of it, and then you place the ICF over the dowels and take a, you know, like a spray sealant along the bottom to fill in the gaps where those nubs were, you know, at the base, and just to adhere it to the top of the footing.
Does anybody have any questions? I think you can unmute yourself. Great. I have used the Micropile in the past for a small little bump out. It maybe came 4 feet off the house. It was like a little bay window, kind of window seat application. And some of the Micropiles didn't go in straight. I mean, vertically straight. We had some problems with them, but where are the pitfalls with the Micropiles in terms of installation? What should we be watching for?
Yeah, you know, when we were watching the installer put in the piers for the deck, he was continually adjusting. I don't know if you could really see in the video. He had his tape measure. He was continually pausing, measuring back to the house. I'm not sure if they give a tolerance, but usually the brackets can offer, you know, if you just provide a flat plate, that would give the most field adjustability in case the tops of the piers weren't quite in the right spot. If something were really off, we've had them just install another one right next to it.
So it's not dissimilar from a traditional sort of full-size helical pier, where much of the time you can drop them roughly where you want them to be, and sometimes you can't, and you either try and brute force your way through it, or you move the piles to other locations and then have to adjust the materials that are spanning between the piles. So that would be, again, comparable to a solution that you'd have with other types of pile systems.
Interesting. Andrew, is there a question in the Micropile thing in your statement? Have you used these before? I think you said you had.
I haven't used Micropiles before, but it just seems like they're so the area above grade is so small in relation to a big sonotube. It seems like they'd be really easy to hide with a skirt board or something like that under a porch, which is a great, in addition to everything else that Allison said about how quickly they go in and how they're less expensive and everything. It just also seems like very easy to sort of make disappear in your architecture.
Yeah, I'll note that this photo was not the final condition. I'm sure they hid those ugly little stubs.
And I'll note that there's some really cool things about using Micropiles. Now, I'm going to back up and say one other thing also. We've been talking about Techno Metal Posts, which is a specific brand, because they're all over this area. They do a lot of great marketing. They have a lot of good information for us technically. There's another manufacturer and installer in the area called Goliath, and there may be more, but we know that Goliath has been on some of our sites or Jason as well. Just so you know, you're not just stuck with one. But the thing that I'm always like, and a lot of our clients are impressed about, is that you come in with your installation rig, you drive the piles in the afternoon, you back the machinery off, and a carpenter can come and start to build right on top of it the moment the machinery backs away. And so it's one of the things that's really terrific. You don't have to, again, wait for the concrete to cure. Well, first you dig a hole and you wait for the building inspector to inspect. Then you pour, you wait for the concrete to cure. Then the concrete folks demobilize, and then the contractor comes back a couple days later and starts the framing. So it's just super fast, super simple, and so it's one of those products that a lot of our clients think is too good to be true with the right application. So we have a lot of fun sharing it.
Matthew, can you talk a little bit about the project where you use the micropiles? Sounds like you use them in a ecologically sensitive area.
Yes. So this was a couple of years ago. It was a rebuild as of right, but it was within, I think, the 25-foot setback of a riverfront. So very sensitive terrain. And I worked with a structural engineer who's since retired, but was very familiar with the systems. And it was a full helical pier, not the micropile. And we were able to get it approved because of those two functions, right? It supported, we assumed it would flood. And so sonotubes would have popped out like corks, and or any foundation would have been stressed. In fact, the main foundation back beyond a certain level had to have floodgates in it for that velocity riverfront. I'm just going back to some of the details, but they installed helical piers. They had some kind of torque gauge capacity on the head of the helical pier, so they went down until they got the capacity the engineer had specified, and they documented that. And then in this particular project, we ended up pouring a bond beam above grade to connect multiple helical piers, and then we built up from there, so with Simpson connectors to deck and house. So that was my experience with them.
Right. If the soils are very loose at the top elevation, a bond beam or a concrete connector element is useful to stabilize the tops of the piers from moving laterally. So that's something we've used once or twice. It starts to erode the elegant simplicity of the system, but it's still a good system in a lot of applications.
And you had a question: who provides affidavits to town for those? Yeah, I wanted to talk about the inspector. I mean, cutting the inspector out, I imagine that could be some interesting conversations.
What do you mean cutting? What do you mean cutting them out?
Well, if I understood correctly, the inspector doesn't have to come out, obviously, because there isn't any rebar or anything like that to inspect before a pour. Would they come out at a certain point after they've been installed? And what are they looking at? And to Anne's point, is there an affidavit that could be provided? Things like that.
I'd say they're looking at the framing above. They're basically looking for us to sign off on the building structure as a whole. And so, we've provided in the past general affidavits that don't specifically identify the helical piles. So if someone came up and had a specific, I'm just trying to think about it. The installer has a known torque. They'll drive to a certain torque, and that torque is a proxy for the bearing capacity. And so I actually, when we're driving large helical piles, there's typically a driving log where you know what that torque is. On these small ones, Allison, I don't think we've seen that before. Is that correct?
Not a log, no, I don't think so.
Yeah.
I do know for a couple projects, the GC or even the homeowners asked for stamped drawings by the manufacturer And that's been kind of an, a separate service that they can provide. They have engineers in-house.
Right, because you have a proprietary product and the manufacturer asserts that you have a certain capacity for a certain diameter shaft. And so we do rely on the industry to deliver what they say they're going to provide.
Mhm.
And that would be similar to, if you have a certain specification for insulation, you don't test it, you don't certify it, you rely on the industry to deliver you an insulation product that has the R value you're expecting. So it's the same here.
Mhm. Interesting. And does that answer your question? We'll take that as a yes. Do we have any questions on the shallow frost protected footing? I've looked at them in the past for projects, but I'm just wary. I mean, talk about the architect's wariness around not going down the 4 feet.
I've built one in.
Go ahead.
So I built one in Vermont, and we called it an Alaskan slab, and it was heavily reinforced. So the theory was that it would move as a unit if it ever moves. It would not crack. So I don't know if that is a factor in some of your designs structurally.
You mean to assume that the whole thing
Well,
would heave up and the slab would then be spanning?
yeah, so I didn't really have time to look at your section, but it seemed like there was a bond beam at the perimeter. And the question is, it's all site specific, right? But would there be expected to be reinforcing rebar going around that bond beam to kind of brace that corner against the impact of whatever frost could hit it?
No, the reinforcing in what you're calling a bond beam, or it could either be called a, just a haunch slab, or just a short section of foundation wall, would just be reinforced to take the structural loads. It's not separately reinforced for any frost action. The idea is that it does not move if we keep the footings warm.
Right. If the soil's warm, it doesn't freeze, you don't have the mechanism that would drive heave. And as a personal testimonial, 15 years ago, we did 2 additions on our house, and we did it. We had our footings were down 2 feet. We had insulation underneath the footing and then extending out all the way around, and hasn't moved. We trusted it in our own situation, but it's been effective, and it's actually widely used in the north, not the I guess the North Midwest. I think you'll find a lot of information on it from designers in Minnesota, Wisconsin, and the like. Their frost depths are deeper than ours, and so their saving potential is much greater than ours as a result.
So at 2 feet depth, sorry for the question. So is there a crawl space, or is it a very limited, or is it just slab on grade?
That was slab on grade in that case, in both cases.
Slab on. Okay.
On both pieces of the building. Yeah.
Okay.
So
And
there's
could
a
you
crawl
review?
space.
I'm sorry. Go ahead, Allison.
A lot of times, if you have a crawl space anyway, it makes sense to go down to frost.
And just to provide headroom.
Right.
Mm-hmm. Mm-hmm. And then that leads to the next conversation. Mr. and Mrs. homeowners, you want to have a full basement for a couple extra thousand, right?
Exactly.
Yeah.
But it could still be useful for if it were a walkout, if grade would start to step down on one or more elevations.
Mm-hmm. And could we review again, how far does the insulation have to go out horizontally from the foundation?
That one is a project specific. It could be, on the order of between 2 and 4 feet.
Okay. It's always a concern of mine that what is the condition of the rigid insulation while it's being installed?
Mm-hmm.
you know, is it torn apart because it's been sitting there a while? You know, it really, we have to have our eyes on it as they're backfilling to make sure that it's continuous and that there aren't major chunks taken out of it, things like that.
Right, but it's not like a rubber roof deck where any minor penetration is a failure. This is not a failure if you've got a little bit of zone where some cold could get down, because you still have a large mass of soil that's insulated and holds the heat.
Yeah, you were saying that in the New England area, it remains at about 50 degrees?
That's right.
Yeah, it's the average, whatever the average annual temperature is in a given zone. It's in the mid 50s, I think, around Eastern Mass. It's probably a touch higher on the Cape, touch lower out in the Berkshires. But pretty quickly you can see that you go down a little bit and the soil doesn't freeze.
Question about that that horizontal rigid sticking out. Is it can you put something on top of it, like at grade, like paving or anything like that? Is there any risk of, I don't know, compromising it with a load on top of it?
No, I mean, you know, rigid insulation has load ratings, and as I noted at my own house, we had the rigid insulation underneath the footings. You might have a few hundred pounds per square inch of capacity, and if you multiply that by 144 square inches per foot, you have a few thousand pounds of bearing capacity on a structural piece of foam, and so there are no limitations to what we put on the outside. I mean, it's common for someone to put foundation plantings and the like, but you can also have a driveway going by, and the load from a car, you know, from a car tire is still going to be way under what the capacity per square foot of a piece of rigid is.
Great. Okay.
Does anybody else have any questions? I mean, once you talk about these systems, you're like, well, yeah, that makes complete sense. You know, it demystifies it completely. When I'm paging through, you know, the magazines and I come across an Icf advertisement, I would always just kind of move beyond it, thinking, oh, I just don't have an application for that. But it really seems like it's very versatile, even in a very conventional sense.
Mm-hmm.
Yeah, we've kind of pleasantly had our eyes opened as well too, once we actually use all these systems, be like, oh yeah, they actually do work.
Yeah, and the ICF system, you know, what they suggest, you know, Allison talked a little bit about the contractor training that's available. They also, most manufacturers have leveling and plumbing systems, because it's all about getting it precisely located. If you get it precisely located, the whole building goes up cleanly. So you have a little less flexibility. If you get your wall up and it's not quite straight, and you're in a small wood frame building, you might be able to adjust it or hit it hard and move it. So you really have to be accurate in your placement. So that's the, you know, one consideration. You want your contractor to be trained and aware of the need for precision, and then comfortable with the use of some of the leveling and plumbing tools that the manufacturers make available. So it's just the one thing. But once that is so, you know, the buildings go up cleanly and they're insulated and quiet, and we've had some success with them. So
if I understand correctly, on the interior finish side, that the interior finish is just directly applied to the foam, or do you put in a kind of nailing board or anything on the interior?
Usually just gypsum right to the foam. We've even seen contractors kind of create their own DIY rigs to cut like a long slotted hole for wiring. They put a chainsaw. What do they do, Steve? It's just like a chainsaw on wheels. And they just like slide it along. Yeah.
Okay.
But your boards can be, your blue board or your sheetrock can be attached to the inserted plastic channels. You remember that the channels that you could see, those black pieces that Ali showed again, they contact the outside of the form. So those are available, or they're close to the outside of the form. So you can, So because you can see where those are located based on the patterns on the surface of the form, you can just put your screws in at those locations. You know exactly where you're going to find a receptive piece of plastic that'll hold the screw.
Mm. Interesting.
Yeah, I'll give you guys a preview. Another thing that we're working on right now, we have lots and lots and lots of questions about lateral force resisting systems, about shear walls and hold downs, things that we want to use instead of moment frames in residential buildings when we can, and lots of questions about what one can and can't get away with. And so we're putting together a little teaching module on that too. We'll be happy to share that with you guys as a group or individually. But again, we find that the more we let our clients know and teach them up front proactively, the easier it is for our clients to initiate designs that will meet the structural requirements.
Krista had a question. Could you share photos of the Fitchburg project you mentioned earlier?
Yeah, I could send them out later with a slide deck if anyone wants. They were part of this presentation. They seem to have left the building.
Okay, thank
Can't
you.
find that file. Okay.
Yeah, I'll see if I could find them.
Steve, do you want to talk about maybe what you're seeing in terms of residential structure, maybe trends that you're seeing, new things that are coming down the pipeline? I mean, what kind of services are you seeing architects request? Where's your bread and butter? Where are you kind of stretching things in terms of design? Do you see any trends lately?
Well, I mean, the probably the biggest trend that we see across the board is a focus on energy savings and sustainability. And so, there are certain tools in the toolbox of a structural engineer. There's something called advanced framing technique. It's got other titles as well, and it has to do with minimizing the amount of lumber that you use in a building. There's a framing factor, which has to do with the percentage of the elevation of a building that has through wall stud work and plates. And as you reduce that, your sort of energy and tactus of the building goes way up. So strategies for reducing the amount of lumber in a building is something that we see a lot. We have been starting to talk and starting to investigate methods for reducing the amount of concrete or the amount of cement in the concrete, because cement production is one of the huge greenhouse gas producers. And so we've been looking at that. We've been getting some inquiries. That involves to use that. It involves the batch plant having the right materials to do that, to change the composition of the concrete. It involves the contractor knowing where to find it. All right, here we go. That's one of the photos from Allison. So probably the biggest trend we see is a focus on energy. And again, our work is supplementary to the design decisions that the architect makes in that case. But we try wherever we can to bring our knowledge to the conversation. Allison, do you want to talk about this at all?
Yeah, this is the Fitchburg building I was talking about. So it's 2 stories above grade, and then the 3rd story, or called the lower level, is a walkout. So grade drops down around when you come around the side of the building. And so it's a garage bay on the left, and then on the right are the residential units. So you can see the decks and patios for every unit that's lettered into the outside the same way that you would letter the floor framing in from the inside.
And this is in Fitchburg, correct?
That's right.
And what was the driving decision-making point here? Was it cost? Was it installation? Was it the site? Wanted to do something different? All of the above?
It was a builder developer who had used this before, and was pretty clear that he could deliver the building more economically using this system.
Uh-huh.
Yeah.
Uh-huh. And quieter, I imagine, or are the interior partitions just regular wood framing?
Metal. You can see if you look
Metal.
at the top. Yeah, in this case we had
Oh
metal
yeah,
framing.
it's that's sorry. Yeah. Okay. That
The
was see some
between
steel up there.
yes, there were some steel beams for carrying the roof trusses.
Okay.
The between unit walls were the ICF walls though.
Okay.
So just the within unit walls were the metal stud.
So you get your fire separation, you get your quiet STC rating, all that stuff in one
Yep.
package.
Yeah.
Interesting. You better know where your rough openings are going though, right?
No, this
Great.
shifting window nonsense.
Yeah, exactly. So are there any other questions? Otherwise, we're at the hour. And if there aren't any more questions, I just want to thank Allison. I want to thank Steve. I want to thank the whole organization. You guys have been wonderful. You've been generous with your time and your knowledge as we've been putting this together. Really appreciate it.
We thank you. Really appreciate it. We like to be able to share what we know as well. So we're glad you were interested.
Great. And you're located in Newton, correct? On Walnut?
Yes. Yep. We're located on Walnut Street in Newton. Our practice area is much of the East Coast. The bulk of our work is concentrated in Eastern Mass and a state or two right around us, but we practice anywhere.
Wonderful. Wonderful. Yeah. And I noticed on one of your recent posts, you have a large percentage of women engineers on staff, which I thought was wonderful as well.
Mm-hmm. Yeah, we have, I think right now we have 3 female engineers and a handful of female support staff, and it's a good mix.
Wonderful, wonderful. Well, thank you everyone for attending, and we'll be in touch about our next presentation.
Right.
Thank you again,
Allison. I'll say one other thing again, as Allison had said, if anyone is interested in the slide deck, you can send us an email or we can send it out through Daniel. I'm not sure, Daniel, what would be the best way to get this out to people?
If you could just type your email addresses in the chat, and then people can take them from there. We'll request the slide deck just to put on our site as a resource, but probably get it faster into people's inboxes if people just either give you their email address or you post your email address in the chat.
Great. And Andy, thanks for the shout out.
No problem. Great to see you.
You too.
Okay. Great. All right, everyone, have a great rest of the day, rest of the week, and rest of the summer. We'll see you in August, hopefully.
Terrific.
Thanks, everyone.
Bye-bye.
Take care, everyone.
Bye-bye.
Bye-bye.